The way we generate our electricity in today's time is majoritarily from coal. So we're pumping a lot of greenhouse gases into the environment. Is this beneficial? Is this necessary? I don't think it is. However, in today's time, this is the only viable option we have. If we have a look into our current national capital region, it has three thermal power plants in its region. And right after Diwali, I am talking on the 23rd of November right now. The AQI in a city like Gurgaon is already over 500, falls in the severe category. Now it made me think, how can we combat an issue which is this prevalent? Because we have one world. Our biodiversity is shrinking, our natural resources are depleting, and let's be honest, I might not live to the age my grandparents are living if we still live in an environment this polluted.
For a sustainable future, energy efficiency and effective light energy management play pivotal roles. Good news is some innovative solutions are already being used. Like in lights, the invention of LEDs has been a game changer, consuming up to 75% less energy than traditional bulbs, while lasting much longer. They have changed the way how the world brightens from dim yellow lights to any color you want, and that too with easy access from your devices. Improving on that, smart lighting systems controlled by motion sensors and timer controlled lights ensure lights are only being used when needed. Motion sensors automatically turn lights on when movement is detected and turn them off when spaces are unoccupied. Timer controlled lights ensure precise scheduling so that the lights are being used only during specific hours. All these technologies, coupled with energy audits and integrated building management technologies, showcase how we can manage energy efficiently and intelligently. However, some of these technologies are still in pipeline, while most of them are not relevant for hostels. These technologies need to be worked upon so that we can make them socially and environmentally acceptable and financially feasible for the larger section of the community. Our team at Thapa is working on a product that can break through the already existing solutions with making almost zero changes.
Now that we are well versed with the problem and the already existing solutions, we move on to our take and initiative to this issue. To begin with our project, we need these items: RC 522, an ESP 32, a NRF 24301, a breadboard, and a bunch of jumper wires. Firstly, we start by connecting the RC 522 and ESP 32. We connect the SDA pin of the RFID to GPIO 5 of ESP 32, SCK to GPIO 18, MOSI to GPIO 23, MISO to GPIO 19, RST to GPIO 27, and lastly, we complete the connections by connecting both the ground and 3.3-volt pins together with each other. Then we move on to the NRF 24301 to ESP2 connections. So we connect CE to GPIO2, CSN to GPIO4, SCK to GPIO18, MOSI to GPIO23, MISO to GPIO19, and ground and 3.3 volt to each other. The common pins in the RFID and NRF are connected by jumper wires male to female. Lastly, to successfully build the entire receiver part, we add a 0.1 mu farad ceramic capacitor across VCC and ground of NRF and RFID close to the pins in order to filter high frequency voice, and a 10 mu farad electrolytic capacitor across VCC and ground of NRF to provide current during smooths and voltage drops. This was it for the transmitter module. Next, we learned to build the receiver end.
Here are how the connections work. The CE is connected to GPIO2. The CSN is connected to GPIO4. The SCK serial clock is connected to GPIO18. The MOSI is connected to GPIO23. The second MISO is connected to GPIO19. Then the ground-to-ground connection provides a common ground connection for both the modules. The VCC is connected to 3.3 volt supply. We place a 0.1 microfarad ceramic capacitor in parallel between the VCC and the ground. The LED circuit has the following components: the LED anode, which is connected to a 220 ohm resistor and GPIO 15. The LED cathode is connected to the ground as it provides a return path to the circuit. The operations are overall are: when the GPIO 15 is set on high, the current flows to the resistor and the LED, thus lighting it up. When the GPIO 15 is set to low, the LED turns off.
So now I will move to the software part, and now I will explain the code for the transmitting module. Below I have included the libraries. The following libraries are the SPI library, the NRF24 library, RF24, and the MFRC52V2 library. Below I have defined the pins, CE pin and the CSN pin. Below I have set the CE pin and the CSN pin to the GPI ports of the Arduino controller. Below I have the two function defined. One is the setup function, other is the loop function. In the setup function, first I have initialized the NRF24L01 module. After that, I have initialized the RFID module. In the loop module, this loop module will constantly check for the new RFID card, and if no card is detected, the loop will continue. If a card is detected, it will get the card UID and send it wirelessly to the other module. In doing so, there is a small delay between each other to avoid any signal spamming. If the card UID is sent, it will print signal sent, and if not, if it will print fail to send signal. This was all about the transmitting module. Now we will move on to the code for the receiving module.
So this is the receiver's code for receiving the data. So first we have added 300 files which are required to connect with the NRF module and provides a user-friendly environment to control the NRF module. Now we have defined 3 pins. First one is CE pin, and the another one is CSN pin, and third one is the LED pin. We have defined RF24 and object name radio for controlling the CE and CSN pin specifically, and the bit address is an address which is same for both receivers and transmitters to communicate with each other. Now setup is a function which is used to set up everything in the microcontroller. Now radio begins is the initialization the NRF modules. If the initialization fails, it will print the NRF24L01 initialization failed. If it doesn't fail, then the program will continue running. Now we are ready to initialize the LED pins. So pin mode LED pin comma output is pin is connected to LED as an output, and it will ensure the LED is off in starting. Now loop is a function for looping the process. Radio.available means check if the data is available or not. If the data is available, then it will store the data in the received message array. Now if the data is received, then it will print the received, and it will turn on the light by digital write LED pin comma high, and it will delay the next code line by 1000 milliseconds, which means for delaying for it by 1 second. And now digital write LED pin comma low, it will turn off the LED pin, and yeah, it was the code for receiving the data.
Technology plays a vital role in modern communication and automation, but no system is without its limitations. Firstly, to eliminate the existing problems in environment, we will be casing a final product via recycled plastic balls. New age companies like Without have mastered in converting MLP waste into reusable plastic pallets, which can be molded in any shape or form. This helps us in ensuring that within the initial stages, we are working for the better of the world as best we can. Active RFID systems and NRF modules require constant power to function. If the energy is sourced from fossil fuels, this contributes to carbon emissions, impacting climate change. But our team is working to make the transmitter module solar powered so that it can be self sufficient and will only take electricity from main supply when needed. One of the issue could be hostlers leaving the card in the socket and going out. To avoid that, we can make sure that before leaving the respective hostels, students have to tap the card at the main gate of their hostels, though other innovative methods can also be approached. So balancing technological advancement with environmental and social responsibility is critical for sustainable development.
So till now, we have discussed about all the key elements of our product. But now, let's talk about the real thing. Let's talk about some money. So in order to make our product both scalable and profitable, we need to start from the initial steps. That is the software part. For the software part, though we are currently using the separate modules for the communication between the two microcontrollers, but later on we are planning to start with the Wi-Fi systems so that both the microcontrollers which are already updated with the latest Wi-Fi standards can communicate over the cloud. This helps in cutting the cost of buying separate modules for the communication. Now, if we talk about the manufacturing, we need to make these things manufactured from the initial points, that is bulk manufacturing. Through this, we can drop our prices to max rupees 1000 rupees. What is this guarantees us is the penetration through the deeper markets, and all kinds of budget hotels can afford this. Yes, our market for this product will be the budget hotels and the hostels. Till now, we have discussed about all the key elements. So this was all about our product.
ये सब तो ठीक है भाई, है क्या ये, करेंगे क्या इसका?
Our plan is to set up this device first in the J hostel. For each room, we will install a transmitting device that will have its own unique key.
We will stick these RFID stickers onto the existing identity card that contains unique key.
As soon as you put the card in, the lights will turn on, and once you remove it, the lights will turn off after 30 seconds.
And the receiver module will be directly attached to the MCBs of the particle room.
This wireless system ensures that we do not have to change a lot in the wirings for the host.
We can put these systems in all types of buildings with some small tweakings.
Guys, चुप हो जाओ.